Good morning, students. So, I'm going to take a class in process scheduling. So, this is one of the important concept of operating system, and it is sub part of process. So, we have already discussed about the process and its different states, how process created, how process destroyed, as well as um, some basic concept of process we have already discussed in the previous class. Now in this class I am going to cover the next part of the process is process scheduling, which is very important concept of operating system. So now uh, first, what do you mean by process scheduling? Okay, the process scheduling is the activity of the process manager that handles the removal of the running process from the CPU and selection of another new process on the basis of particular strategy. That means process scheduling is the activity of the process manager to select new process after completing the old process for the CPU to be executed. So, process scheduling is an essential part of a multi-programming operating system. Such operating system allows more than one process to be loaded into the executable memory at a time and loaded the process share the CPU using time multiplexing. So it is very important part for the multi-programming operating system. Now, what do you mean by process scheduling queues? So when operating system maintains all process control blocks in process scheduling queues, the operating system maintains a separate queue for each of process state. So we have already discussed 5 states of the process. Now, for each of process states, operating system maintains separate queue and process control blocks of all process in the same execution state are placed in the same queue. When the state of a process is changed, then its process control block is unlocked from the current queue and moved to its new state queue. So, in general, the operating system maintains the following 3 types of queues, scheduling queues. So, why it is scheduling queues? Because for scheduling purpose, this queue are used. So there are 3 scheduling queues we have in general in operating system. Number 1 is job queue. So job queue means this queue keeps all the process in the system. What job queue means? It queues all the process in the system. Number 2, ready queue. This queue keeps a set of all process residing in the main memory, ready and waiting to execute. A new process is always put in this queue. Ready queue means ready to execute. So it is waiting, and all new process to be executed is actually queued in the ready queue. So next, another queue which is device queue. So the process which are blocked due to unavailability of I/O input output devices or other reasons constitute this queue, device queue. Means if some problem occurs, then queues are again then process are again queues in some queues. So it is device queue. So how happen this diagram will be clear. So job queue, from job queue means the system where the all process are queued, then it goes to ready queue. Ready queue means it is ready to be executed. So from ready queue it dispatches to CPU, and CPU takes process to be executed from ready queue, and finally if completed correctly, then it exits. So if not, if some happens, again from CPU, if process is blocked or due to some interrupt, then process comes again waiting, input output waiting queue, and then that is nothing but input output. It is also a device queue. Then from device queue, after getting the resource of required information of input output, then again it goes to ready queue, and from ready queue again it goes to CPU. So this is the mechanism. Now OS can use different policies to manage its queue: FIFO, fast in fast out, round robin, priority, etc. So the OS scheduler determines how to move process between ready and run queue. We can OS scheduler, operating system scheduler, determines how moves, what is the strategy, FIFO or round robin, and between ready and run queues. So which can only have one entry per processor core of the system. In the above diagram, it has merged with the CPU we have seen. Now there are two-state model. Two-state model means there are only two states model refer to running and non-running states, which are described below. Means only two states, running and not running. So when running state means when a new process is created, it enters into the system as in the running state. And not running means processes are not running, are kept in the queue waiting for their turns to be executed, and each entry in the queue is a pointer to a particular process. So queue is implemented by using linked list. Use of dispatcher is as follows: when a process is interrupted, that process is transferred in the waiting queue. If the process is completed or aborted, the process is discarded. In either case, the dispatcher then select a process from queue to execute. So now come the important is scheduler. What is scheduler? So scheduler is a special system software. It is a set of programs, or scheduler is a special system software which handle process scheduling in various ways. Scheduler handles the process scheduling mechanism. So their task is to select the job to be submitted into the system and to decide which process to run. So schedulers are three types: long-term scheduler, short-term scheduler, and medium-term scheduler. So how scheduler do scheduling, then we see in base of three types of scheduler. Long-term scheduler, it is actually nothing but it is also known as job scheduler. So a long-term scheduler determines which programs are admitted to the system for processing. So it is slow scheduler. So it determines which programs are admitted to the system for processing. Then it selects processes from the queue and load them into memory for executions. So process loads into memory for CPU scheduling. The primary objective of job scheduler is to provide a balanced mix of jobs such as input output bound and processor bound. So there are two types of alternative cycles: input output cycles and processor cycles. So it also controls the degree of multiprogramming. If the degree of multiprogramming is stable, then the average rate of process creations must be equal to average departure rate of the process leaving of the system. So the long-term scheduler actually keeps stable of multiprogramming system. So on some system, the long-term scheduler may not be available or minimal. Time-sharing operating system have no long-term scheduler. Remember, time-sharing operating system have no long-term scheduler. When a process sends the states from new to ready, then there is use of long-term scheduler. Now come to short-term scheduler. It is also known as CPU scheduler. Its main objective is to increase system performance in accordance with the chosen set of criteria. It is the change of ready state to running state of the process. So CPU scheduler selects a process among the processes that are ready to be execute and allocates CPU to one of them. So short-term scheduler is also known as dispatcher. So this scheduler selects the process among the process from the ready queue to execute and allocate CPU. So make the decision of which process to execute next. So short-term scheduler are faster than long-term scheduler. Now come to another medium-term scheduler, which is also a part of swapping. So medium-term scheduling is a part of swapping. It removes the process from the memory. It reduces the degree of multiprogramming. The medium-term scheduler is in charge of handling the swapped out process. So which will be the swapping, which process will be swapped out, this is determined by the medium-term scheduler. So a running process may become suspended if it makes an IO request. Input request, a suspended process cannot make any progress towards completion. So in this condition, to remove the process from memory and make space for other new processes, the suspended process is moved to the secondary storage, and this process is known as swapping, and the process is said to be swapped out or roll out, and new process will be loaded into the memory, and swap may be necessary to improve the process mix. Now in this way we can get three types of scheduler. Now we can make comparisons among schedulers. So long-term scheduler, short-term scheduler, and medium-term scheduler. So first is, it is a job scheduler. Second, short-term is also known as CPU scheduler, and medium-term scheduler, it is a process swapping scheduler. So job scheduler, CPU scheduler, and swapping scheduler. Number 2, speed is less than short-term scheduler. Long-term scheduler is slower. Then speed is fastest among other two scheduler. So short-term scheduler is fastest, and speed is between the short-term and medium. The medium-term scheduler implies the speed is between faster than long-term scheduler and slower than short-term scheduler. So now number 3 points, it controls the degree of multiprogramming. Long-term scheduler controls the degree of multiprogramming, and short-term scheduler provides lesser control over degree of multiprogramming. Number 3, that is medium-term scheduler, it reduces the degree of multiprogramming. Number 4, it is almost absent, minimal in time sharing system. So long-term scheduler is almost absent or minimal in time sharing system, but it is also minimal in time sharing system. So short-term scheduler is also minimal in time sharing system, but medium-term scheduler is a part of time sharing system. So availability of medium-term scheduler in case of time sharing system is more than that of long-term and short-term scheduler. Now number 5 point, long-term scheduler selects process from pool and loads them into memory for execution. So pool of process there, and long-term scheduler loads them into memory for execution. But the CPU scheduler, that is short-term scheduler, select those processes which are ready to execute. So when processes are ready to be executed, then that process are selected by short-term scheduler or CPU scheduler. But in case of medium-term scheduler, it can be reintroduced the process into memory and execution can be continued. So swapping is done here. Now come to context switch. So it is another very important concept of process scheduling. A context switch is the mechanism to store and restore the state or context of a CPU in the process control block, so that a process execution can be resumed from the same point at a later time. So using this technique, a context switcher enables multiple processes to share a single CPU. So context switching is essential part of multitasking operating system. Context switch means, what is context switch? If you can actually lots of processes there, then which process will be executed by the CPU, and after that if some problem occurs, then that process is suspended, then their context, their states are stored in the memory space, and again it is resumed from the same point and later, and it is done by context switching. So now when the scheduler switch the CPU from execution one process to execute another, the state from current running process is stored into the process control block PCB, and after this, the state for the process to run next is loaded from its own PCB and used to set the program counter, register, etc. At that point, the second process can start executing. So how happen? What do we see? This is CPU cycle. So CPU, suppose process 1 is executing by CPU, then some problem occurs, some interrupt happens, then it saves the states in the process control block, then CPU take the process P2 for execution, then restore program counter state of process 2 states, again process 2 after if some problem occurs, then process 2 again save states, and then process 1 is resumed. So and restore the state of process 1, and process 1 is resumed by the CPU. In this way we can suspended some processes and new processes are taken by the processor, and suspended process again resume in the same state from the information of process control block. Now context switches are computationally intensive since register and memory states must be set and restored. To avoid the amount of context switching time, some hardware system employ 2 or more set of processor registers. When the process is switched, the following information is stored for later use. So when process is switched means if some process are suspended, a new processor comes, then switch process have some informations. So program counter, scheduling information, base and limit register value, current use register, sense state, input output state information, accounting information, etc. So this is how context switching happen. Now we come to another some basic concept of scheduling, process scheduling. So what is the basic concept? The main purpose of CPU scheduling means process scheduling is maximum CPU utilization obtained with multi-programming. So there when process are executed by CPU, then there are 2 cycles, CPU and input output burst cycle. The process execution consists of a cycle of CPU execution and input output waits. So CPU burst means when CPU loads store from the file and wait for input output, so input output burst, and again CPU burst, so store increment index write to file, again waiting for input output in input output burst, again load store read from file, CPU burst. So we can alternate, we can get 2 states, CPU burst followed by input burst, again input output burst followed by CPU burst. So CPU burst distribution is of main concern. Now CPU scheduler we have already discussed. Short-term scheduler selects from among the process in ready queue and allocate CPU to one of them. So queue may be ordered in various ways. CPU scheduling decisions. When CPU scheduling, the decision may be take place when a process. So one decision switch from running to waiting stage. Number 2 switch from running to ready stage. Number 3 switch from waiting to ready stage, and 4 terminates. So when scheduling under 1 and 4, it is non-primitive scheduling. So scheduling is two types, non-primitive and primitive. So under the condition 1 and 4, one means switch from running to waiting and then terminates, so it is non-primitive. That means in non-primitive scheduling you cannot forcibly take the process which are executing by the CPU. But in all other scheduling is primitive. Primitive means switch from running to ready and switch from waiting to ready. So we can, in primitive scheduling, we can forcibly take the executed process when some higher priority process comes. So now dispatcher we have already discussed. Dispatcher module gives control CPU to process selected by the short-term scheduler. So context switching to user mode, jumping. The dispatcher latency means it is the time duration, that is the time that takes for dispatcher to stop one process and start another process. So stopping one process and starting another process, the time between is known as dispatcher latency. Now important scheduling criteria. So there are very important concept. What is the criteria of scheduling? CPU utilization. So first criteria is CPU utilization. So CPU, it keeps the CPU busy as possible. We actually maximize the CPU utilization so that CPU is busy 100%. We try scheduling criteria's main factor is CPU utilization, so it should be maximized. Next, throughput. Throughput, the processes that complete their execution per unit time. So number of processes that completed their executions per unit time is nothing but throughput. So we always have maximum throughput. Next, turnaround time, the amount of time to execute a particular process. So it is the time amount to execute a particular process. It should be minimum. It should be minimized, turnaround time. Then waiting time also, amount of time a process has been waiting in the ready queue. It should be minimum for better scheduling, so that waiting time should be minimum. And a response time, the amount of time it takes from when a request was submitted until the first response is produced, not output. So it is also, we need minimum response time for better scheduling. So this is the scheduling criteria. Now scheduling algorithm optimization criteria. So maximize the CPU utilizations, max the throughput, minimize the turnaround time, minimize the waiting time, and minimize the response time. So with this I conclude my lecture of process scheduling, and next we will meet in the next class, process scheduling algorithm. So thank you very much.